Okay, here's where we left off the other day. We were looking at graphs of trig functions, graphs of sine and cosine. And we started looking at what all these letters A, B, C, and D do to our graph. And it doesn't really matter if you're dealing with a sine wave or a cosine wave. A, B, C, and D all do the same thing. What does A do? What does A control? A is amplitude. And what does amplitude mean? What's another word for amplitude? What I was really looking for was vertical stretch. Stretches it up and down. So A equals the amplitude, which is another word for vertical stretch. What did B control? B controlled horizontal stretch. And when we're talking with sine or cosine, we call that period. So our period is 2 pi over b. And what that means is that's how long it takes the wave to make one complete cycle. How about C? Was what? Which was called phase shift, which is another word for translation horizontally. All right, so our phase shift actually deals with C and B. We saw in the graphs we looked at the other day. The phase shift, to figure out the phase shift, to figure out how far horizontally, left or right, your graph is moved, it's C over B. And finally D, we didn't look at D, but people yelled out what D was at the end before we left. What's D? Your shift up and down. So D gives your vertical shift. Okay, so using all that information, we're going to draw some very nice graphs here. I give you y equals 3 sine of x plus pi over 2. And the directions, and this will be the directions that you're going to have on your test on Friday. The directions will be determine the amplitude, the period, and the phase shift of the function and graph it by hand. And when you graph it by hand, I'm going to expect you to give me 5 key points. So we'll talk about those in a second here. First off, what's my amplitude?
3.
That's the easiest one to figure out. The amplitude is 3. What's the period? 2 pi over, not over x, over 1. The number right here is the number 1. So our period is 2 pi. No change there. How about our phase shift? How far left and right is this graph moving? Pi over 2, which direction, left or right? Left. Why left? Because that's got a plus. Remember, our original formula has bx minus c. So if c is a positive number, that means we're going to have a negative here, which is a shift to the right. If this is a positive, that means c is a negative number, which means a shift to the left. So our phase shift is going to be minus pi over 2 over 1, which is minus pi over 2. So we're actually shifting to the left there because of that plus. And finally, how about our vertical shift up and down? Lindsay?
So for the period B, it's just assumed that you know that it's there. You don't know anything.
Assume what's there?
2 pi.
Well, the period of sine and cosine always starts at 2 pi,
Okay.
and then B changes it. So if this had been the number 2 here, we would have had 2 pi over 2. If this were the number 5, we would have said it's 2 pi over 5. So whatever this number is here, that changes the period. The period always starts at 2 pi, changes based on that number. All right, how about our where were we? Vertical shift. What's the vertical shift up and down? 0. How come? Because there's no, actually it would be D, that number C, there's no D number. So no vertical shift. All right, that makes it pretty easy. All right, so now how am I going to start graphing this thing? A sine wave usually starts at 0, 0. This one does not start at 0, 0. It starts at negative pi over 2, 0. Why negative pi over 2, 0? There's no D, there's no vertical shift, but we do have a horizontal shift. We have a phase shift. Normally my sine wave would start at 0, 0 and go up and down like so. If there was no phase shift, we would start at 0, 0. That's correct. But we have a phase shift, which means we're starting there. So there's your first key point that you're going to mark. Minus pi over 2, comma 0. My sine wave is going to go up and come back down. Where's it going to stop? Stops where? I think I heard the right answer. Okay, so what's my period? My period is 2 pi, which means I'm going to start here. I'm going to go up and back down, and eventually I'm going to come back to the axis. This distance here, from here to where it ends, is going to be 2 pi. So if I'm starting at minus pi over 2, and I'm going over 2 pi, where do I stop? 3 pi over 2. Why 3 pi over 2? Because if I had started at, normally it would end at pi over 2, but I'm phase shifting over a minus pi over 2. So this is where it's going to stop. So there's my second key point. It's going to stop at 3 pi over 2, comma 0. All right. So that's how I begin. I always find the starting point and I find the ending point. Then I find the middle point. What's halfway between minus pi over 2 and 3 pi over 2? Well, just looking at the picture, it looks like the halfway point is pi over 2. And I would agree with you, it is pi over 2. What would you do if you couldn't tell so easily from the picture? You would add these two things together and then divide by 2, simply average them out. So this is pi over 2, comma 0. So there's 3 points. All right, so this graph starts here, and it's going to go up. How high up is it going to go? It's going to go up to a maximum height of 3. When is that maximum height going to occur? Why at 0, 3? I agree with you completely. It's the midpoint, once again. Halfway between minus pi over 2 and pi over 2 is the midpoint, and that's going to be x is 0. So there's our high point. We got one more to go. What's the last point we need to find? Our low point. Where's our low point? Pi negative 3. Why pi? It's halfway between these two. And why negative 3? Because our amplitude is 3. All right. So we play a nice game of connect the dots with a sine wave. And that's the answer I would expect to see on your test.
So if the amplitude was negative 3,
Good question. What if the amplitude were negative 3? What would be different? We would go down to 0, negative 3, and we would be up to pi 3. So if the amplitude were, the amplitude is always given as a positive number. The amplitude is given as 3. But if this had a negative in front of it, you're absolutely right. The graph would simply be flipped. It would go down and then up, like so. Other questions on that one? All right, how about number 2? Very similar, except now I'm dealing with a cosine function. What changes? Cosine, when we draw a cosine, we usually start at 0, comma 1. So we start up high. So we're not going to start at 0, 0, we're going to start at 0, 1, and we'll do our shifting stuff from there. Okay, so for this graph, tell me about the amplitude. It's a half. Amplitude is a half. Tell me about the period. 2 pi. Period always starts at 2 pi. And then you divide by whatever the b number is. The b number in this case is 4. So the length of one cycle this time is only going to be pi over 2. Won't be 2 pi this time because this is going to be a shorter cycle. How about the phase shift? Pi over 4. Excellent. Why pi over 4? Because it's the c number divided by the b number. And again, remember, this is an easy mistake to make. Remember that our formulas had the minus built in from the beginning. So if I have a minus pi, that means my c number is really the number positive pi. So my phase shift, I take the c number, which is pi, divide it by the b number, that's 4. And once again, how about a vertical shift up and down? We don't have one. And it didn't even ask for it, did it? Because there isn't one. All right. So normally, if I were to draw a cosine graph, if I just had y equals cosine x, normally I would start at the point 0, 1. Where am I going to start this graph? My height is only going to be a 1/2. So my y value is going to be a 1/2. What about my x value? Not 0. Pi over 4. Why pi over 4? Because that's our phase shift. We're not starting at 0 anymore. We're now starting at pi over 4. So I'm going to call it
positive because there was a minus sign in the
correct. The original equation had this minus sign built in, which means positive, which means we move to the right. Opposite of this one had a positive here,
so it's negative.
and our phase shift is negative. That's correct. So that sign always changes, so be careful of that one. All right, so this point right here, I'm going to call this point pi over 4, 1. Oh, no. Crap. Oh, well. Good thing is I hadn't scaled my axes, so I can still call it pi over 4, 1/2. So this is a height of 1/2, and this is a height of 1. That's okay. Screwed up, but I can still make it work. Just call it what I need it to be. Okay, so cosine graph. Cosine graph starts high, goes down, and then comes back up, correct? So I'm going to start at pi over 4. Where am I going to end? No. What do we call the distance from the start to the end? That's called begins with a P, period. So I'm starting at pi over 4. I end pi over 2 later. So if I start at pi over 4 and I have to go to the right pi over 2, where am I ending? Oh, I think I just got to add my fractions, right? I start at pi over 4 and I add my phase shift. That's pi over 2. What's pi over 4 plus pi over 2? 3 pi over 4, because it's pi over 4 plus 2 pi over 4. We've got common denominators there. 3 pi over 4. So that's where I'm going to end. Okay, so where in this picture is 3 pi over 4? Between pi over 2 and pi, so it's right here. So this is a very short cosine wave. Starts here. It's going to go down and come all the way back up, and it's going to end right there. Very short wave. Is that surprising? It shouldn't be surprising because our period is only pi over 2. Our period is very short. Normally the period is 2 pi. but we had to divide by that 4. So this is the point 3 pi over 4, comma 1/2. All right, what has to happen in between? It's going to go down. How far down is it going to go? Down to a low value of y equals negative 1/2. And where is that going to happen? It happens halfway in between. What's halfway in between pi over 4 and 3 pi over 4? Pi over 2. Again, it looks it in the picture. Again, if you're not convinced, simply take pi over 4, add 3 pi over 4. That gives you 4 pi over 4, which is pi, and then you would divide that by 2. All right, so our low point is halfway in between. That's at pi over 2, comma, negative 1/2. All right, so it goes down, turns around, goes back up. We have 3 of our 5 important points. What are the other 2 important points? The what? Well, what do you mean by endpoints? To me, I've already kind of got the endpoints. The other 2 important points I should find are these intercepts. So notice the points that we're finding on these graphs. We're finding the intercepts, the high point, and the low point. For the cosine graph, you find 2 high points and 1 low point, and then 2 intercepts. Okay. Where is this intercept right here?
Pi over 3.
And how did you get pi over 3?
It's in between pi over 4 and pi over 2.
It's in between pi over 4 and pi over 2, and I agree that pi over 3 is in between. But I don't think pi over 3 is the right answer. But you got the right idea. Pi over 3 comma 0? That's a better answer. Still don't think it's correct though. Pi over 3 I don't think is the right x value. I want it exact, right down to the pi. Describe where it is in words to me. In between is correct, but you can be more specific. Where in between? Halfway in between. So what's halfway between pi over 4 and pi over 2? Well, we add them together. So we're going to take pi over 4, and we're going to add pi over 2, and then we're going to divide it by 2. It's halfway in between. Things are always halfway in between here. What's pi over 4 plus pi over 2? We already did that once, didn't we? We got 3 pi over 4. What's 3 pi over 4 divided by 2? You think of 2 as being 2 over 1, you flip and multiply. That's 3 pi over 4 times 1/2. That's 3 pi over 8. So there's where that point is. This one is 3 pi over 8, comma 0. One more to go. That one right there. Five pi over 8. Excellent. 5 pi over 8, comma 0. How did you come up with 5 pi over 8?
Well, to get to pi over 2, you have to add 1 start with 4 pi over 8. So then go 1 more to 5 pi over 8.
Correct. Here's the way I tend to think of these. Once I get these points labeled, my biggest denominator is an 8. So I turn everything into 8s. So this one would be 2 pi over 8. This one is 3 pi over 8. This one is 4 pi over 8. So the next one would be 5 pi over 8. So you can just count 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8. Or the other way to do it would be the way that name and lose me right now. Take pi over 2 and add, it's got to have another pi over 8 moved over. Questions on that one?
Can you use the same thing for sine?
You can use the exact same thing for sine. This one, I think the numbers turned out easily enough that we could see halfway between minus pi over 2 and pi over 2 was simply 0. So this one turned out to be pretty easy. We could just do it that way. But same trick would work if you had other numbers. Should we do one more of those? All right, let's do one more. Unfortunately, I don't have one on the sheet. We'll do the back sheet here in a minute. I'll just have to do it on paper. Y equals. Give me a number for A. 4. Do we want to use sine or do we want to use cosine? Sine. Give me a number for B. 2 is easy? You sure? You don't want it to be easy?
No, because you're probably not going to make it easy on the test.
5.
Depends on what kind of mood I'm in, I guess.
You're coming in a bad mood, stop it.
How about a 3? We'll go with a 3x. Do we want a plus or a minus?
Plus.
Plus?
Well, make it minus on the top of it.
Make it a minus?
Yeah, true.
No, make it a plus.
Make it minus.
Well, I listened to one student for one answer, so I'll listen to the other for the other. So I made it easy with
You
the...
still said remember 2 things.
No, you said you didn't want the 2, so I made it a 3. You said you wanted it hard, I made it
You
hard.
suggested sine, I suggested cosine, though.
Oh, sorry, I missed that. Sorry. Okay, well, we'll live with that. All right, give me a number here. Pi over 2. Wonderful choice. All right, so there, we want to graph that.
Let's do a D. We do a D.
You want a D? Oh, you guys are going nuts here.
Plus 2.
Plus 2. All right, let's throw a D into this one. Amplitude.
4.
4. Period. Two pi over 3? It's always 2 pi, and then you divide by that number, 2 pi over 3. Phase shift. Pi over 2. That's almost right. Over 3. The phase shift is always this number divided by that number. What's pi over 2 divided by 3?
3 pi over 2.
Not 3 pi over 2. Think of 3 as being 3 over 1.
Yep.
Flip and multiply.
Oh,
It's pi over 6. And then our vertical shift. 2.
that doesn't change. So plus 2 is not 0.
Yep, that one doesn't change. It's only this one, because this one has the minus sign built into the formula. Okay. Normally, if I were gonna draw a sine wave, I would normally mark my first point as 0, 0. This time my first point is not 0, 0. What is my first point? Pi over 6, 2. Excellent. Y is my first point. Pi over 6, 2. Because my phase shift says don't start at 0, start pi over 6 to the right. And my vertical shift says don't start at y equals 0, start 2 places up. So your phase shift and your vertical shift give you your starting point. Okay, good? Okay, sine wave goes up, down, and up. Ending. Well, I think you would agree with me that my y value is going to be 2. Lindsay?
Pi over 6b, like on the graph, if we had a graph like we usually do.
Yeah, if I gave you this graph, where would pi over 6 be?
Yeah.
You would kind of have to estimate it.
Okay.
If this is pi over 4, pi over 6 is a little bit smaller.
Okay.
And pi over 3 would be a little bit bigger. So pi over 6 would be right about there somewhere. So it doesn't come out great on that graph. Okay, anyway, do you agree with me that the y value here is going to be 2? Yes. X value. Not 2. I have to add something. I'm starting at pi over 6. And what do I have to add? I have to add my period. So I take my starting x value and I add my period. That gives me my ending x value. So, come off to the side here. Pi over 6 plus 2 pi over 3. That's pi over 6 plus 4 pi over 6. That looks like 5 pi over 6. Good so far? Looking good? All right. What's next? Find the midpoint. Okay. On my midpoint. Once again, I think without doing much work at all, I know the y value. What's the y value? Still 2, isn't it? Because we're straight across here. So my y value is 2. Okay. But then I need halfway in between. What's halfway between pi over 6 and 5 pi over 6? Not pi. Not pi over 2. Oh yeah, pi over 2. Sorry. Pi over 2. How did you get pi over 2?
I added the 5 pi over 6 and pi over 6 and divided by 2.
Correct. To find the midpoint, you add these together. Pi over 6 plus 5 pi over 6, that's 6 pi over 6, which is a fancy way of saying pi. And then you divide by 2. So I agree completely after I think about it for a minute. Pi over 2. All right, 2 more points to go. This one right here. First off, I would like you to tell me the y value.
4.
I heard somebody wanting to say 6, it sounded like. And then I heard some 4s. Crap, I heard a crap.
It's 4. 6. 6.
Why is it 6? Because we started at 2. Our amplitude is 4, which means we start at 2, we have to go 4 higher. So amplitude doesn't tell you what the high point is, it tells you how much higher. So we have to go to a high point of 6. How about the x value?
Pi over 3.
Pi over 3? How'd you get pi over 3?
I changed everything to the 6th and then just did like 1, 2.
Okay, all right, so I like that. I like what you're thinking.
Like how you did.
This is pi over 6. This would be 3 pi over 6. So what's in between pi over 6 and 3 pi over 6? 2 pi over 6. And 2 pi over 6 is a fancy way of saying pi over 3. Again, your other option would be to simply add these together, take pi over 6 and add pi over 2. But how do you add pi over 6 and pi over 2? You get a common denominator, don't you?
Yeah.
So that's really what he did. So he said pi over 6 and 3 pi over 6. Halfway in between is 2 pi over 6. That's pi over 3. All right, so our last point, doing that same sort of trick. This was pi over 6, 2 pi over 6, 3 pi over 6. The next one is 4 pi over 6, which we would write as 2 pi over 3. And how about the y number? Excellent, -2, because we started at 2 and we go down by 4. So our y value would be -2 there. Questions? All right then, let's look at these last two. Now we're going backward. Now I'm giving you the picture, and I want you to tell me the equation. That's always harder, by the way. It's like playing Jeopardy. I give you the answer and you tell me the question.
Wait, I can tell you the answer.
You can tell me the amplitude. Wonderful start. What's the amplitude?
Negative 3. B3. Negative 3.
Amplitude is always given as a positive number, so we would say the amplitude is 3.
Cosine.
Is it a sine wave or is it a cosine wave?
Could be both.
It's either, right? Depends on what you think about. If I start here and go along, then I'm thinking it's a sine wave. Maybe I start here and do one's complete cycle and it's a cosine wave. Which one should you use? Whichever one you think is the easier one. And I'm hearing a vote that I think cosine is the easier one. And then I'm seeing a vote, no, cosine is not the easier one. Okay? For somebody saying cosine is the easy one, why is cosine the easy one? What's that? Well, I can find my 3 high and low points. 1, 2, 3. Other points are easy too. Yeah, but if I'm dealing with sine, my points are easy too. They're here, here, and here.
You don't have to do any horizontal shifting.
Cosine is easier because you do not need a phase shift. Perfect. Why don't you need a phase shift?
There's a point on the y-axis.
Because we have this point on the y-axis, which is a low point. So our amplitude is going to be 3. If we choose to use cosine, if we use negative 3 cosine, we're not going to need a left or right shift, because all we've done is we've taken the cosine graph, which would normally start here, and we've flipped it upside down by putting that negative on it.
But can you just say that it's a sine graph with a vertical shift down?
No. But if it's a sine graph shifted down, then it would have to go up and down from here. Sine graphs kind of start in the middle, actually, and then they go up and down and back to where they started. Dan, did you have a question?
I was going to say the same thing. That was going to be negative 3.
Yeah. We're going to do this one twice, by the way. We'll do it once with a cosine and once with a sine and see which one we like better. But you can use either. Mike?
I thought you said we could have negative amplitude.
Amplitude is always given as a positive number.
Okay.
This number can be negative. This number can be negative 3. But then we say the amplitude is
Oh, 3, okay.
3.
Okay.
So this number can be negative, but amplitude is always given as a positive number.
Okay.
Okay, so if I start here and I do one complete cycle, boom, 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 that means I end right there. So what's my period?
1.5.
My period is pi. So I know that pi being my period, that has to be 2 pi over the b number. So that means the b number better be 2. So I think a correct answer for this is simply negative 3 cosine 2x. I don't need a phase shift because one complete cycle goes like so. So I think for this problem it's easier to use cosine. So I did. But let's do the same problem using sine. If I'm using sine, then what I'm thinking is I'm starting here and going to there. So if I'm using sine, what's my amplitude? 3. The amplitude doesn't change, does it? If I'm using sine, what's my period? It doesn't change. It's still pi, which means my b number is still going to be the number 2. What does change? We have a phase shift. What's our phase shift? Pi over 4. So, to find my phase shift, I take b divided by c. which means b divided by c would have to be pi over 4. But we already figured out the b number. What was our b number again? 2. Our b number was 2. So I know 2 over c has to be pi over 4. How would you solve that equation? Cross multiply. So c pi is 8. Which means c would have to be 8 over pi. So if I wanted to write this as a sine wave, I would write y equals, my amplitude is 3, sine of 2x minus 8 over pi. So when you use a sine wave and a cosine wave, some of the numbers are always going to be the same and some of them are going to be different. What numbers will always be the same? The amplitude will always be the same, but sometimes you might want to put a negative on one of them for convenience. The amplitude will always be the same. What other number will always be the same? The b number will always be the same, because the period is always the same. The d number is always the same. What's the d number for both of these? It's the vertical shift. What was the vertical shift on both of these? 0. It was the same. What's the only letter that's going to be different? The phase shift. So the c will be different. For this problem, the c was 0. For this one, the c was 8 over pi. A, b, and d will always be all the same if you're using sine or cosine. It won't matter which one. The only number that will be different will be the c number. Okay, so a real problem. I got this data off of weather.com. This is the average high temperature each month in the city of Corning for the last year. Average high temperature. The average low temperature looked pretty much just the same, by the way. It was just lower, of course. I want to know an equation that fits that data. Okay. I could plug it in my calculator, but I'm going to do it by hand because I like to. And then we'll do it on our calculator and we'll see how close our answer comes. Lindsay.
So how would we do this without seeing like a phase shift?
Excellent.
Period?
Yeah, so we got to figure out all those things, don't we? We got to figure out the phase shift, the period. Well, I do think we're seeing one complete cycle, though. Right? We're going up and then back down to where we started. So it kind of looks like where are my pictures here? So it's kind of like an upside down chunk of a cosine wave. We're starting at our low, we see where our high is, and we come back to our low. So it kind of, to me, looks like a chunk of a cosine wave. We got a low, up to our high, back down to our low, then it's going to go up again and down again, so on and so forth. All right. Well, so you're absolutely correct. We need to find out the amplitude. We need to find out the period. We need to find out the phase shift. And we need to find out the vertical shift. Can anybody give me any of those numbers? I'll give you a hint. The period's the easiest one.
Where's a 1?
Or 11.
Or 11.
1 or 12?
One what?
1 year.
1 year would be correct, except notice that our data is given in months. So 1 year is 12 months. So our period is 12. Which means, how do we find period again? 2 pi over the b number has to give me 12. So what does the B number have to be? Well, how would you solve that equation? Think of 12 as being 12 over 1 and cross multiply. That means 12b has to be 2 pi, which means b is pi over 6. So there's our b number. Our b number is pi over 6. Let's shoot for the amplitude next. Any thoughts on amplitude? 30 something? And how are you figuring this out? Well, in fact, if you look at our data, our lowest is 33 degrees and our highest is 81, correct? So 81 minus 33 gives you 48. So what's the amplitude? Nope.
No.
Let's go back to this cosine graph that we drew a minute ago. This had a high point of a 1/2 and a low point of a negative 1/2. So what's the distance between the high point and the low point? 1. But what was the amplitude? Half of that. So to find the amplitude, you take the high point, which is 81, you take the low point, which is 33, you subtract them, that's 48, but your amplitude is only half of that. So your amplitude is 24. Okay. Well, we're halfway there. Only 2 more things to figure out. Phase shift. The phase shift is not 33.
Zero?
Would not be 0. When you start a cosine graph, where does it usually start? It usually starts at 0, comma 1. This one is starting at, what's the x number? First month, right? So normally we start at 0, comma 1. We're starting at 1, comma something. So how far to the right did we slide? 1. Our phase shift is 1. We slid 1 unit to the right. So, how do we normally find phase shift?
C over B.
C over B. So that tells me, since I know B is pi over 6, what's my C number? Well, how would I get C all by itself? Cross multiply. What's 1 times pi over 6? And what's C times 1? C is pi over 6. All right, we're almost there. What's the vertical shift?
Did you just take half of 81?
Half of 81?
No.
40 and a half?
Yeah.
Okay. I don't think that's right. But let's find out. Okay, so what I did is I went ahead and I typed that data into my calculator. So there's the data. It's in L1 and L2. And I'm going to type in the equation that we have. We have 24 cosine of, our b was pi over 6, pi over 6x, minus, our c was pi over 6, over 6. And then we took a guess at our vertical shift of 40.5. Let's graph and see how it looks. What do you think? Do we have the right equation?
The amplitude might be negative.
Yeah, it certainly looks like we got a problem, don't it? It certainly looks like our graph is upside down. So how do I fix my graph being upside down? Make my A number be negative. Why should my A number have been negative? Cosine graph usually starts high and goes low, doesn't it? What's this one doing? It's starting low and going high, so my A number certainly should have been negative. All right, so I'll fix that. All right. Now what can you tell me? Our vertical shift is wrong, isn't it? Otherwise it looks pretty good. If I could just take this cosine graph and slide it up a little bit, it looks like it's going to match pretty well. So our vertical shift must be wrong. All right, so let's go back to this one where we did a vertical shift. Our vertical shift was 2. How does our vertical shift relate to our highest point and our lowest point? What's that? Our vertical shift was 2. What's that have to do with those two numbers?
Once you add them up and you divide by 2, you get.
It's halfway in between. It's the same halfway in between trick, except now we're doing the y values. So our vertical shift should be halfway between our high and our low. Our high was 81, our low was 33. So I add those together with 81 plus 33. $114. What's half of 114? 57. So I think if we change our vertical shift to 57, I think we'll be pretty darn good. I gotta get the angle right so the light reflects off it so you can see. How'd we do? I think we did pretty darn good. Questions on that? Now let's see what the calculator does. What I mean by that is let's go stat, calculate. For trigonometry, the calculator only offers a sine regression. It doesn't offer a cosine. So I'll have my calculator figure out the sine regression. Y equals, let's plug it in here. Here's what the calculator says you get if you do a sine regression. Is their answer better? Slightly. I mean, if you go back and look at the graph, it's slightly. But let's look. We said our amplitude was 24. The calculator says the amplitude should be 24.6. Pretty close. We had pi over 6 for our A number, for our B number. Calculator, it'd be easier to look here, I think. The calculator says the B number should be 0.50. What's pi over 6? Well, pi is about 3.1. 3.1 divided by 6 is about a half. So we agree pretty much there. What do we have for our up and down shift? We had 57, they got 56.8, pretty close. The only number that's dramatically different is the C number, because you got to think of the phase shift. You can't see the C number. The C number is dramatically different, and that's what we would expect.